All right, guys. Last week you looked at question numbers 16 to 21 and you found the vertex and you told me whether your parabola was facing up or facing down. And how we did that, we looked at our vertex form of a quadratic function where y equals a times x minus h squared plus k is our formula, and that hk is your vertex. And so if we look here, it says minus h, and this says minus 1. So our h, our x coordinate of our vertex, is going to be positive 1. And then our k, our y coordinate of our vertex, the formula says plus 3 plus k, and we got a plus 3, so it's positive 3. Then I asked you to tell me if the parabola is facing up or facing down. So if we look here at A, since we have nothing showing, we've got an invisible 1, and that's positive or negative. Positive. So our parabola is facing up, like a U, not a U-turn. Okay, so like this. And now today I'm asking you to look at questions 16, 19, and 21. And I want you to make an input-output table so that you can graph them in your book. So to do that, I'm going to use this space I have over here. I want you to use a separate piece of paper, but this is just so we can see everything at once. I want you to give me 5 points. So the first one you've already got, it's your vertex. 1, 3. And if you make your input-output table at the same time that you're graphing, it'll save you time. So let's see, you can say oops, let me erase that. I can't draw a straight line. Come on, straight line, work with me. Okay, that's supposed to be my y-axis, and everything's positive, positive, so my x-axis is coming down the bottom here. Okay, we've got a vertex at 1, 3. So where x is 1, y is 1, 2, 3. We've got the vertex, and we know it's going to be facing up. Okay, so if to use my input-output table, I have to make up values for my x. So I'm going to pick x values that's close to the x value of my vertex. I'm going to pick 0, where x is 0. Now to fill it in, I'm going to use that formula. I'm going to just change f of x to y equals, I'm going to leave the x blank, minus 1 squared plus 3. And then I'm going to plug in this 0 from my x. 0 minus 1 is negative 1. Negative 1 squared is positive 1. And then 1 plus 3 is 4. So when x is 0, y is 4. And because I know that, I know I'm making a parabola facing up, I also know that when x is 2, y is 4. And then now I can check when x is negative 1. I'm going to erase that 0 and put a negative 1. Negative 1 minus 1 is negative 2. Negative 2 squared is going to be positive 4. You can check it on the calculator. 4 plus 3 is 7. where x is -1, y is 7. 1, 2, 3, 4, 5, 6, 7, right here. And now, because it's a mirror image, I also know that when x, let's see, mirror image is going to bring it right here. When x is 1, 2, 3, y is also 7. And that's 1, 2, 3, 4, 5 sets of data that give me these ordered pairs over here so that you can make your graph in the book. And I'd like for you to get this done in about 15 minutes for number 16, number 19, and number 21. So pause the video while you work on number 19 and 21. And then once you got them, come back and we'll look at the next couple of questions. I asked you to answer question number 31. Let g of x be the function whose graph is a reflection in the x-axis and translated 3 units right of the graph of f of x. So your f of x is x squared. So we take our parent function and let's see, so g of x equals, and we know we're working with vertex form, so I'm thinking of my formula while I'm writing this down. Y equals a times x minus h squared plus k, where hk is my vertex. A tells me whether my parabola is facing up or facing down. It also tells me if it's skinnies up to be a vertical stretch or if it gets short and fat to be a vertical compression. So x something squared, a reflection in the x-axis. So I want you to look in your notebook where we wrote about transformations. What does a reflection in the x-axis look like? A reflection in the x-axis. You should see that you multiply outside of the parentheses times -1. So we just put a negative out here. Then we got it's translated 3 units to the right. So movement to the left and right goes inside of parentheses. And if we look on our axis, moving it to the right means we're moving in the positive direction of the x's, but we notice the pattern that when it's inside of parentheses, we do the opposite. So it's going to be -3 or +3 here if we're moving right 3. You can look on your transformation page in your notebook, and you should be able to get that. And what'd you get? What'd you get? -3. And that's it. That's our answer for number 31. And then I also asked you to look at question number 36. Load. Question number 36 doesn't want to load. Okay, there it goes. The graph of g of x equals 3 times x minus 2 squared is a transformation of the graph of f of x equals x squared. Describe in words the sequence of transformation that takes the graph of f to the graph of g. So f of x would just look like this, right? That's f of x. And then g of x, this is similar to what we had as an example last week. This minus 2 is going to move it in what direction? This minus 2 inside of parentheses is telling us to go 2 units. Is that to the left, right, up, or down? Tell me on that line. What are you going to fill in on that line? Left, right, up, or down? And when I look at it, I can see I'm going 2 units to the right. So our vertex moved here, and no up or down because there's nothing after the square outside of the parentheses. And then this 3 does what? When we're looking at those transformations of quadratic functions, always it's that letter A, it's outside of the parentheses. It's going to be a vertical shrink or compression. Shrink or stretch, because a shrink is a compression. A shrink or stretch by a factor of 3. So this 3. And when we see that, we know that our points are 3 times more. So 3 times 0 is still 0, 0 right here for our y. But our x's are going to be 3 times higher. So wherever this next x was, boom, we're up 3 times higher. So three times higher. We can see it's skinnier, and that is a vertical stretch. It is skinnying up. So we moved 2 units to the right, and we had a vertical stretch by a factor of 3. So those were like review from last week. And now you can look on my notebook. You can ask the sub to go grab my period 6 notebook. I got this written down for you. Page 54, example number 2. Identify the vertex, axis of symmetry, minimum or maximum, domain and range of the function f of x equals negative x plus 4 squared minus 5. So we're gonna first of all find the vertex. Once you find the vertex, you kind of have most of all of the other information. So our vertex, think about the formula. Y equals a times x minus h squared plus k. I hope you're getting that memorized. Our vertex is at hk. So if I look here, the formula says negative h, but we got a plus 4, so it's going to be the opposite of positive 4 for our x coordinate of our vertex. Our h is going to be negative 4. And our k, our y coordinate of our vertex, the formula says plus k, but we got a minus 5, so that's going to be at negative 5. And then your axis of symmetry, once you have the vertex, the axis of symmetry is right here. It's the x coordinate of the vertex. And your axis of symmetry is always going to be a equation is going to be at x equals -4. So what this is looking like -4, -5. One, two, three, four. 1, 2, 3, 4, 5. When x is -4, y is -5. That's our vertex. And we're going to have a graph. Let's see. When x is 0, 0 plus 4 is 4 squared. Oh, I went the wrong way. That's okay. 4 squared is 16, but it's negative. -16 minus 5, -21. Our y-intercept is going to be way down at -21. So our graph is going 1, 2, 3, 4, 1, 2, 3, 4, something like this for our mirror image, right? Parabola. And because A is negative, we know we got a parabola facing down, and our y-intercept would be way down at -21. And this axis of symmetry is this line right here, where you make a vertical line that turns your parabola into its mirror image. So if you folded the parabola on this green dotted line, they would have the same points on top of each other. That's our axis of symmetry. And it always just comes from the x coordinate of the vertex. So we got the vertex, the axis of symmetry, and do you have a minimum or maximum? Looking at the graph, our vertex is at the top, so that's a maximum. And it's at -5. That comes from the y coordinate of your vertex. So our maximum is our y at -1, 2, 3, 4, 5. And if A was positive and our parabola was going the opposite direction, then it would be a minimum at -5. And then domain, for all of the f of x equals x squared and all of its transformations, the domain is all real numbers. So -infinity to +infinity. And then the range, we can see that as x is approaching -infinity, y is approaching -infinity. As x approaches +infinity, y is approaching -infinity. So our smallest range, our smallest y value is -infinity. It goes up, it stops at -5, and it goes back down. So our range is from -infinity up to 5. And on that 5, we give it the bracket, and on the -infinity, it gets the parentheses, and this both gets in parentheses. So domain and range. And again, if our A had been positive here instead of negative and it was flipped around the other way, then the range would have been 5 would have been the minimum instead of a maximum. So the range would have been from 5 and then going up to positive infinity. That is if A was positive. But since A was negative, that's not our range. This is our range for this question. And now you're going to look on your book on page 57, number 12, 14, 15, and then page 58, numbers 22 to 25, and then question 32, 34, and 38. If you got a handle on your attributes of quadratic functions, you can answer all of these questions, even the word problems. Don't overthink all of these questions that I gave you. If you can identify the vertex number 1 and then relate that to the other attributes of quadratic functions, you're going to be able to answer those questions rather quickly. And then on Thursday, when we come back together, we're going to be writing the formula of a quadratic function given the vertex and another point. So you guys are done with the video. If you're ready to work on your questions, I'm just going to look at a few of these, but I'm not going to be giving any answers to any of your classwork. Number 12. A classmate said that the vertex of g of x is equals -5, x plus 2 squared minus 4 is 2, 4. Is your classmate correct or not? What is the correct vertex? So you're going to take this given quadratic function in vertex form and relate it back to the formula. Y equals a times x minus h squared plus k. Did they get the vertex correct or no? And if they got it wrong, what is the correct vertex for number 12? They got it wrong. Fix it. Number 14. Explain why the graph of the equation g of x equals -x plus 1 squared minus 3 would be a parabola going downward. Y equals a times x plus 1. Oops. X minus h squared plus k. What tells you which way the parabola faces? That A right there. And how do we know if it faces, opens upward or downward? If A is positive or negative. So if A is greater than 1, or if A is not greater than 1, if A is greater than 0, or if A is less than 0. And we got negative, invisible 1, -1 is less than 0, so that's how we know we have a parabola going downward. And number 15, you got a 2-part question. I'm going to go straight to the question first. how far away is the ball from a Maya when it's at its maximum height? Right there, that's a key word. This you may see on SAT next week. My sophomores who are taking SAT, PSAT. Right away, I know the maximum is the y coordinate of my vertex. So if I go back up to the question, Amaya is standing 30 feet from a volleyball net. The net is 8 feet high. Amaya serves the ball. The path of the ball is modeled by the equation y equals negative 2/100 x minus 18 squared plus 12, where x is the ball's horizontal distance in feet from Amaya's position and y is the distance in feet from the ground to the ball. So if I look at the formula, I know that HK is what? So how far away is the ball from Amaya when it's at its maximum height? So that's the max height. And then that h, whatever number you get there from your vertex, that's the distance. So you're just identifying the vertex to answer that question. And then part B, how would you find the ball's height when it crosses the net at x equals 30? So using your input-output table that we did for questions 16, 19, 21 helps you with this. You're just going to take the formula and plug in a 30 for the x and then use a calculator to solve it. So y equals negative 0.02. Make sure you're following your order of operations. Plug in a 30 where the x is. And then you'll have the height when the distance is 30. And then down here, questions 22 to 25, straightforward. You either have to write small or use a piece of separate paper to give us your attributes of quadratic functions, just like that example. And then you got 32, 34, and 38. Compare the maximum heights of the two sets of shoes. So by looking here, this is similar to the other word problem. Maximum height, maximum, keyword maximum. That's the y coordinate of your vertex. That's all you're comparing. Number 32 and number 34. The curvature of the Tacoma Narrows Bridge in Washington is the shape of a parabola, and we can see the parabola right here. In the given function, x represents the horizontal distance in meters from the arch's left end, and f of x represents the distance in meters from the base of the arch. What is the width of the arch? So, the width of the arch. So from here to here, all the way across, right? And we can see our vertex would be in the middle, right about here. So we know the distance from here to here. halfway across the arch is what? From the vertex, the x coordinate of your vertex. So if that's halfway across, what's all the way across? What do you got to do to the x coordinate of your vertex? Just multiply by 2. And then you have your answer to the first part. Oh, you have your whole answer. And then the last question was number 38. And it's taken a minute to load. The Bluebird Bakery sells more alfajores when it lowers its price, but this also changes profits. The profit for the alfajores is f of x equals negative 500 x minus 4500 squared plus 400. This function represents the profit earned when the price of an alfajor is x dollars. The bakery wants to maximize their profits. What is the domain of the function? We said that for a quadratic function, the domain is all real numbers, but in this case we got a word problem. So would it make sense for the bakery to be making a negative amount of cookies, pastries? Probably not. So that wouldn't make sense. So they could make 0, and they could make, I mean, I guess technically up to infinity, but probably not. But I think that's where they're going with this. They could make from 0 to infinity pastries. So that would be the domain, because we're looking at a graph would be number of, wait, is it number? No, it's the price of the alfajores. Price. So they wouldn't have a negative price, my bad. So the price would start at 0. I mean, they're not really gonna give any away. And then up to an infinite price. If they're selling it for infinite amount of money, no one would be able to afford it. But so from 0 to infinity is going to be our domain, and then depending on what's the price, that's going to be the profit. And we can tell by the vertex that we have a maximum profit. The y coordinate is going to be that maximum profit. They want you to find the daily profits for selling alfajores for 40 cents each and for 75 cents each. So just like we did with our input-output table, you're going to take the formula and plug in 40 cents for the x, plug in 75 cents for the x. What is the profit at each of those prices? And then part C, what price should the bakery charge to maximize their profits from selling them? The maximum profit is given at the vertex, the y coordinate of the vertex. That's the maximum. So what's the price with that maximum profit? That's the x coordinate of the vertex. That's it. And that's all I'm asking you guys to do today. I hope that you have a productive class period and you're able to answer all of your questions that deal with graphing a quadratic function or deal with the attributes of quadratic functions. I'll see you guys later.